Groundbreaking advancements in ANSYS R17 allow structural simulation from electrical CAD data. What this means is that ANSYS now provides a complete flow to address electrical, thermal, and structural challenges in electronics. Typical problems impacting performance and reliability are power and signal integrity, EMI, vibration, thermal effects, and mechanical stress. ANSYS has developed a unique chip package system, or CPS, flow to detect problems early in the design phase. The simulation is comprehensive, carefully examining the interaction from electrical to thermal to stress in an integrated environment. Electronics is at the heart of many systems. Simulation tools from ANSYS accurately predict the electronics behavior to increase product reliability and performance. Reliability is especially important for mission-critical electronics found in transportation. Here's an example of a printed circuit board used in a typical consumer electronics product. ANSYS semiconductor tools analyze the ICs to produce their electrical and thermal models to be used for package and board simulations. ANSYS power integrity analysis couples IC models with package and board models to compute and minimize power losses on the PCB. Heat generated by the ICs plus power losses in conductors within the package and board raise the temperature of the system. Heat from the ICs and conductor power losses are the input for detailed computational fluid dynamics-based thermal analysis. The simulation ensures temperatures across the PCB do not exceed design limits. Localized temperature increases cause thermal expansion and stress that can significantly reduce product reliability. Computing this thermal stress is critical but challenging due to the enormous geometrical complexity of electrical CAD data. Revolutionary capabilities in ANSYS R17 for the first time enable structural simulation of ECAD data by forming 3D layered solid parts and mapping the metal fraction data onto the finite element mesh. The metal density is mapped across the board and is used in the finite element simulation. Now we're set to complete the electrical, thermal, mechanical flow that enables you to understand potential causes for faults in the board. The temperature field from CFD analysis is mapped onto the model. The heat will cause structural deformation. Deformation is concentrated in regions of high temperature gradients, especially under the ICs. You can also see high levels of stress due to thermal expansion. These effects could potentially lead to delamination of IC packages and boards, or even breakage of component solder joints. For example, when you attach a package to the board, the thermal-induced board deformation stresses the solder joints. In this example, the stress is maximum at the corners of the IC package, and it can even crack a solder joint, causing system failure. ANSYS is breaking new ground in multiphysics design to boost reliability of electronics products. Only ANSYS provides a complete CPS flow to address the electrical, thermal, and structural challenges. Only ANSYS.